Hey everyone, welcome back to my number sense series. In this video, we're going to talk about something called number counting. Now, number counting is not a phrase that is commonly used, but it's a phrase that I think describes what we're about to do pretty well. And number counting is what I'm going to use as a stepping stone into our next few videos, which will be on arithmetic sequences. So consider what you learn in this video and the next one on number counting to be very crucial things that we're going to do in arithmetic sequences, especially this one. This one I would say is the most important with arithmetic sequences, and then it kind of branches off into number counting too and arithmetic sequences. So please try your best to understand this video. You can absolutely leave a comment if you're confused, or just rewatch the video a few times. So let's get right into it. Number counting. By number counting, I mean these kinds of problems. For example, how many numbers are there from 1 to 100 inclusive? Where inclusive just means we're counting both 1 and 100. Sometimes if you hear the word exclusive, you'll just know that means not counting 1 and 100. But usually what you're going to hear is inclusive, so we're going to count 1 and 100 by default. So how many numbers are there from 1 to 100? Well, I'm sure a lot of you on instinct said 100. And that would be correct. There are 100 numbers from 1 to 100. Very nice. But then when I teach this, I often ask a follow-up question. How many numbers are there from 10 to 100 inclusive? And then a lot of people automatically say 90. They say 90 because they think, well, it's 10 to 100, so I'll just do 100 minus 10, and that gives me 90. But 90 is actually not correct. Because, if you did find the number of numbers by subtracting, then you'd have 100 minus 1 equals 99. And clearly the answer isn't 99. So what's going on here? Well, the answer, I'll tell you right now, is 91. And that seems a little bit weird to a lot of people when they first hear it, but hopefully when I explain it, it'll all make sense. So when you do subtraction, let's try to visualize what you're doing, right? So imagine like a number line, like this, with 1, 2, 3, 4, 5. Now, what subtraction is doing is finding like the distance between two numbers, right? For example, 1 jump, 2 jump, 3 jumps, 4 jumps. 5 minus 1 is 4, and there are 4 jumps between 1 and 5. So that's what subtraction is doing. But what we want to do is count the number of dots. This is known as the fence post problem. It's a very, very common pitfall for new mathematicians. Very, very common. I first fell for this. The fence post problem is counting fence posts versus counting gaps. Subtraction is counting the gaps. What we want to do is count the fence posts, which are the numbers. And so you might notice that the fence posts are just one more than the numbers. And so you might think, okay, well, in order to find the amount of numbers, I can just do subtraction and then add 1. And then you would be correct. In general, the amount of numbers from A to B is going to be just B minus A plus 1. And if you plug this into our first question, you'll see that we get 100 minus 1 plus 1 equals 100. Very nice. So hopefully, this kind of visual explanation helps you understand why subtraction is not correct, but subtraction is very close. All we have to do is add 1 to account for the fact that we're doing fence posts, not gaps. So, with that done, let's think about a little bit of a different problem. Because instead of adding 1 now, we're going to add 2. So, let's think about it. How many numbers are there in the sequence 2, 4, 6, 8, all the way to 100, inclusive, of course? Well, some of you might think, okay, well, this is just the even numbers. All right, but, well, it is the even numbers, so how does that help us? Well, one thing that we might want to do is think about the sequence like this. Well, instead of thinking 2, 4, 6, 8, why don't I just divide them all by 2? If I divide everything by 2, it keeps the amount of numbers the same, right? I'm not adding any numbers, I'm not deleting any numbers, I'm just changing them. So if I divide them all by 2, what do I get? Well, if I divide them all by 2, I get 1, 2, 3, 4, all the way to 50. Well, that sounds really familiar, right? That's just 50. That's like the same as these two problems, just with 50. So I might think that the answer is 50, and I would be correct. The answer is 50. But then you might start thinking, well, I don't want to do this division every time I want to do a problem like this because As you can see, there are a lot of problems like this. So what's a way that I can streamline it a bit more? Well, let me tell you. In general, I'm going to write out a general case here. If I have a plus d, a plus 2d, all the way to b. So these are just numbers I'm writing. So here, a would be the starting number, a is 2, b is the ending number, b is 100, and d is what you call the common difference. The common difference is the number that you add like each time. So here the common difference would be 2, because to get 4 you add 2, to get 6 you then add 2 to this one, then you add 2 to get to 8, then you add 2 to get to 10, all the way until you reach 100. That's why d is 2. So let's make a note. A equals 2, d equals 2, b equals 100. So if I have a sequence like this, then the amount of numbers in the sequence is going to be equal to b minus a over d plus 1. Now, if this looks a little bit complicated, please don't be afraid, because if we understand where this formula comes from, it will all make sense. Essentially, what I've done is incorporated this idea of dividing by d into here, and we can actually see that if d is equal to 1, like in these, then it's the same as b minus a plus 1. So all I've really done is added a divided by d. So now let's try to use this formula, b minus a over d, all plus 1, on here. So b is 100, so it's 100 minus 2 over 2 plus 1. That's going to be 98 over 2, which is 49. 49 plus 1 equals 50. Wow. So our formula works. And this is our formula. Please try to understand this formula. Really what I'm doing is fence posts again. That's it. So how many numbers are there in the sequence 2, 5, 8 to 11 to 101 inclusive? Well, this is simply a retextured version of our last problem. So if we remember the formula, it will be very easy. So let's try to plug in the formula, and then after that, if the formula still doesn't make sense, I will give you a visual explanation. So if we plug in the formula, we get 101 minus 2, that's the last one and the first one, and then now let's find the common difference. The common difference is, once again, like the gap, right? The gap is 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3. So, clearly d is 3 plus 1. So what does this give us? This gives us 99 over 3, all plus 1, which is 34. So the answer is 34, but if that doesn't quite make sense with the formula, let me show you in a bit of a different way. Let's do the fence posting again. 2, 5, 8, 11, 14, 17, and this continues all the way to 101. All right. Now, once again, our visual idea of subtraction is like finding distance, right? If we find distance, we're finding like the distance. So then when I divide the distance by d, what I'm finding is the number of gaps I have. For example, if I'm at the distance 6 and then I divide by 3, that tells me I have 2 gaps. 2 gaps of length 3 each make a distance of 6. Hopefully that makes sense. So that means a distance of 99 if each gap has length 3, that makes 33 gaps. 33 gaps. But I don't want gaps, I want fence posts. So how can I get from gaps to fence posts? Well, it's just like in here, in order to get from gaps to fence posts, I just add 1. For example, if I have 1 gap, that means I have 2 fence posts. If I have 2 gaps, that means I have 3 fence posts. If I have 3 gaps, that means I have 4 fence posts. So that's why I'm going to add 1 at the end. That's where we get this plus 1. Hopefully that visual explanation made sense. So that gives us 34. Now, let's try one more practice problem with a bit of a larger number. 6, 17, 28, 39. But don't be afraid, it is still the same idea. So try to use the formula. It's going to be 226, that's the last number, minus 6, the first number. So you can kind of think of it as last minus first over difference plus 1. last minus first over difference. What's the difference? It's 11 plus 1. Okay, that gives us 220 over 11 plus 1 equals 21. And that's our answer. Of course, you could have tried to do this by, simply counting it out, but that would have been way too inefficient. And if you need this visual in your head to help you understand, that's totally okay, but please try to understand, just the formula by itself so you can apply it much quicker in competitions. So that's this problem, what I would call the second hardest one maybe. And now we have reached the last problem. And something different you might notice in the last problem is that the numbers are decreasing. And some people, when they see a different variation of this problem, they immediately get scared and they think they can't do it. But of course, they can do it. Because it's not really anything different. The numbers are just decreasing. What's so bad about that? Well, let's see. Well, first of all, one thing we can do is just apply our formula. Let's see if our formula still works. Well, a formula tells us that the answer is last minus first over, now what's the common difference? The common difference is 64 minus 67, which is negative 3, then plus 1. That gives us negative 66 over negative 3 plus 1, which is equal to 22 plus 1, which is equal to 23. That is the correct answer. But if you don't want to use these negative numbers in your calculations, here's one thing you can do. Instead of writing it this way, just write it backwards. If you write it backwards, the terms are still the same. You're not adding anything, you're not deleting anything, you're just kind of swapping them around. So, they're still the same amount of terms. So if you swap them around, if you flip this backwards, what you get is 1, 4, 7, 10, all the way to 67. And then maybe this makes more sense to you and you can apply the formula that way. But in my opinion, it is best to simply be familiar with the formula, be comfortable using it, and simply trust the answer it gives you. So that is number counting 1. This is finding the amount of numbers in what I would call the nicer sequences. But this is going to be a extremely crucial concept in both our video on number counting 2 and also arithmetic sequences. I would say this is probably the most important thing you have to know for arithmetic sequences, or one of the two most important things. So please try your best to understand this video. If something still doesn't make sense, absolutely leave a comment. I'll answer it as soon as possible, or watch the video back, ask Google, anything like that. But yeah, as long as you understand this, you will be set up very well for our next 2 videos. I hope it makes sense. Thank you guys for watching, and I'll see you next time.